Hey, thanks everybody for coming. My name's Alex Raichev, and I'm going to talk about a niche thing here, Python for public transport. So if you're a civic hacker, this will be of interest to you. If you're not into public transport, then, well, there's another talk going on, too. So. Everything I'm going to say, I put these slides up on GitHub, and I'll show you more about that at the end. So don't worry. If I go through too fast, you can check it out again. So my name's Alex. I like math, algorithms, Python. And I work at MR Cagney in Auckland, which is a public transport, walking, cycling consultancy.
Sorry.
Sure.
Wellington bus driver, sort of Cagney, don't make me forget.
And at my workplace, I have the joy of using Python on a daily basis to analyze and visualize civic data, mostly civic data. And public transport is one kind of such data. I probably look at that weekly. Just before I dive into this, big thanks to my employer, MR Cagney, for sponsoring my trip here. So there are three main kinds of public transport data. I might also use the word transit, which is a synonym for public transport, so just heads up. The three main kinds are scheduling data, when and where the vehicles are promised to be, real-time data, where they actually are, and ticketing data, who's on the vehicles. I'm going to focus here today on scheduling data, because this is just a half-hour talk, and I think you'll get a flavor of this with just focusing on one here. So we're going to talk about where and when vehicles are promised to be. And fortunately, there's a universal standard for scheduling data. It's called General Transit Feed Specification, or GTFS. It's the most popular open standard. A lot of transit agencies publish their scheduling data in this format. It was developed by Portland's TriMet Transit Agency and Google in 2005. And there's hundreds of such feeds available for poking around analysis. Some uses of, you might say, well, what's the point? I'll just publish my schedule in a PDF, and there you go. There's your schedule. You know what buses are coming when. Well, having this nice, human and machine-readable format of GTFS allows you to analyze the data and do a lot of automated things. For instance, Google Maps uses just GTFS data to route you from point A to point B when you say, click on the bus icon. I want to go to the conference from wherever. I want to take the bus. You can also use these feeds to measure performance of transit agencies, like how many service kilometers are they using, sort of transit nerd stuff. And also to answer whimsical questions, which we'll do today. Oh, I should also say, this will be like a zip-through tour, but if you have any questions, feel free to politely interrupt me if I spoke too fast or you missed something. So today I'd like to dive into GTFS and using Python with GTFS. With a running example, I'm going to use a local example, Wellington's latest transit feed. I got this from transitfeeds.com. Oh, no. I meant to open that in a new tab. That wouldn't work. Transitfeeds.com is a nice website. It hosts and archives GTFS feeds from all cities, lots of cities around the world. Here's Wellington's Metlink, and here's an archive of their GTFS feeds. I downloaded ahead of time here this latest feed from July 22nd. Transit agencies publish their feeds according to different timelines. Looks like pretty frequently for Wellington here. Okay. What is this feed that I'm talking about, this GTFS feed? It's just it's basically a dump of a relational database. It's a bunch of CSV files with the .txt extension. I don't know why they did that, but it's CSV. They're CSV files. And they encode lots of different information about the scheduling data. So for instance, stops.txt. Stops.txt is a file with these headers in it. The stop ID, that's an internal ID for the stop. The stop code, which is usually a public-facing ID for the stop. I know in Auckland, our bus stops have the stop code printed on the signs. Maybe you, I haven't checked out the Wellington signs. Maybe they do. The name of the stop, corner of blah and blah, something like that. The stop latitude and the stop longitude, the actual geolocation of the stop, and other things. Here's a file, here's the head of the CSV file for Wellington stops. So you got stop ID, stop code. It looks like the stop codes are the same as the stop IDs in Wellington. Reynolds Street at Milne Crescent, here's where it's located, etc. So that's some stops data. That's where the stops are, what they're called. And then you also have routes.txt, for instance, that tells you route data, a route ID, a route short name, which is probably more familiar to people. That's the public-facing name of the route, like 300, whatever. Route long name. Here's an example from Wellington. Route ID 3000, agency ID TZM. Route short name 300, Whenua Tapu Cemetery, Porirua, Titahi Bay, etc. This is the description of all the routes, just their names, etc., and their IDs. A route is a collection of trips, trips.txt. A trip is a run, a single run of a vehicle, such as a bus or a train. Just one run from here to there, along with all of its stops. So a route has many trips, and here's the nitty-gritty of a trips file. It's not particularly nice looking, whatever. Maybe you recognize the trip head sign. I don't know, this kind of weird looking head signs for these. Anyway, trips are runs of vehicles, and stoptimes.txt, oh sorry, back up. Shapes.txt is the geodata of the trip. It's the path, the geographic path that the trip follows. So it's a bunch of longitude, latitude coordinates for that trip. So it's pretty good. Now you know, we're piecing together lots of data here for the route, the paths that they take. And the stop times here, this is where most of the scheduling data is. This is a file with, you have a trip ID, and you have an arrival time, a departure time, and a stop. So it's like trip, stop, time, arrival, departure. Same trip, different stop, another time, et cetera, et cetera. So that stop times is where the scheduling data is. Okay, so it's complex, this spec. But it's rich in information, and it's just begging to be, have some software to digest it and analyze it.
Is that data available to anybody to come to queries on?
Yes.
So it's like the last 4 years, I've been asking the owners of the network comparison figures about wheelchair accessible trips before and after changes made.
So there is, about that particular question about wheelchair accessibility, I think that's...
If you do have it as one of the parameters there, that's why I was wondering why they didn't define it. If it's too complicated.
Yeah, so that's in the, where is it? Where did you see that? Is that in the routes.txt? Was it in trips? So wheelchair accessibility. Yeah, so it looks like Wellington, that's an optional field, and it looks like Wellington is filling out that field. Oh, there's also bikes allowed. So, oh, hang on, it's blank. So the feed is out there, but it could use some more data in it. And as I say, warning, if you're playing with this stuff, there's the spec, and then there's what the agencies actually publish. Some of the fields are optional. And sometimes the fields are required, and just like the feeds are invalid, so you gotta validate the feed too. So Wellington's, I would say at least it's a valid field. I've checked this out. It's a valid feed. That's good. There's a link to the GTFS, the actual specification for your reference. I won't go into that, but we kind of looked a little bit about the component files and their fields. So we want to, here's a challenge for the next several minutes. We want to use the Wellington GTFS feed in Python to answer the following whimsical questions. What is the most or least frequent route? What is the shortest or longest distance route? What is the slowest, fastest route? You probably take some, if we Wellingtonians out there, take some guesses along the way. Oh, yeah. That's so, this is now gets into questions of scheduling data and ticketing data. So I'm going to keep it simple for today, but that is a good question. And I should say ticketing data is often guarded. So you're not going to get it as a public, as just a regular member of the public. You're going to have some contacts with the transit agency. They're going to have to hire you for a job to release that data, because it's usually confidential for business reasons. Because they don't want the operators, they don't want operators to know like the patronage on their different routes and then be like, hey, wait, you're getting more money for these routes and things like that. So the real-time data is, it's sparser. It's not, Auckland has a real-time feed. I don't think Wellington has a real-time feed. That, yeah, some of these things are highly political. Like you can compute some stats on these, on the performance of these networks, and be like, this is not what you promised, actually, with real-time data and the scheduling it. So scheduling data, easy to get. Real-time data, not often published. Ticketing data, good luck. OK, so let's content ourselves with these little challenges here. I use them mostly for pedagogical reasons. All right, tackle these challenges. How are we going to handle these CSVs, Pythonistas? The CSV module, database, any suggestions? What would you do if you were starting from scratch? Pandas. Ooh, I like that suggestion. That's so a few years ago when I was tasked with this sort of thing, there wasn't a lot of software, there wasn't any good software out there for analyzing GTFS feeds. There was once, Google had some software for validating the feeds and maybe merging some feeds, but not actually analyzing them. And so I wrote some software to do that. It's called GTFSTK. And it uses Pandas and Shapely to do all the hard work. Pandas, if you don't know, is a fantastic library for manipulating tabular data, which is what we have here, a bunch of CSVs, a bunch of tables. And Shapely is a Python library for manipulating spatial data, which is also present in these GTFS feeds. As far as I can tell, this is the best library for GTFS feeds. I wrote it, but it is open source, so contributors welcome. And yeah, I would expect by now that something better would be out, but no. So I'm going to use GTFSTK to answer some of these questions. And along the lines, introduce you to it a little bit. And if you're into this, I highly recommend using it, or if you let me know if you find a better software package. OK, so we've got some notebook snippets here from Jupyter Notebooks. Any fans of Jupyter Notebooks, users out there? Great. I like Jupyter Notebooks. They're super handy for prototyping and encoding workflows. I'm not going to do any live coding. That's kind of dangerous. I didn't bring my computer with me as well, so we're gonna look at screenshots of Jupyter Notebooks here. So importing GTFSTK and Pandas. I'm gonna load the Wellington feed. I have 2 of them stored. I'm gonna use the latest one. Here's this. Let's read the feed. So feed now is it's basically a bundle of Pandas tables, Pandas data frames of trips, stops, stop times, et cetera, all the GTFS tables that we saw. So after this command is finished, feed is now an object that contains all those tables. And there's some few methods like describe, where you can get some basic info about the feed, like the start date of it, the end date of it, the number of routes. Apparently there's 99 routes in Wellington. So you know that. And 2,888 stops. And there's also a validator in GTFSTK, which is important. Don't trust the transit feeds that you get. They could be invalid. Validate them first. Wellington's is valid. There's a bunch of warnings for some dodgy encodings, but no errors. You could also see that in transitfeeds.com also does some validation for you. See, they have some warnings as well. They'll warn you if a feed is bad. So. OK, so let's play a little bit with Pandas to look at some of this information. And this is kind of just like a reminder of some of things that Pandas can do, or an introduction to some things that Pandas can do for manipulating tabular data. Feed.trips is that trips.text table. This is the transpose of it, just so you can see the column header there. So with Pandas, you can filter columns, or like slice by columns if you want. Here's feed.trips.filter. I only want the root ID, trip ID, shape ID columns. Boom, there it is. So I can slice a table vertically. You can slice a table horizontally, just slice by rows with Pandas. If you use the loc command, here's feed.trips, loc, and I'm giving into it a function that says, just give me the rows where the root ID is 6. I only care about root ID 6. And there you go. You can slice your table that way. Basic things. You can also group tables with Pandas, which is handy. If I want to group by the root ID, split up this trips table into groups where each group has the same root ID. And you can get individual groups if you want. And now something a little more fancy. This is common Pandas idiom, split, apply, combine. Split your table into groups, like by roots, your trips table into roots, and then apply to each group a function, and then paste it back together into a new table. Split, apply, combine is the idiom. And here is an example of taking feed.trips, grouping it by the root ID. Can you see my mouse? OK. Applying this function, which I called myag, which all it does is count the number of trips. It counts the number of rows in that group, which is equivalent to the number of trips. And then, OK, there's an extra command here, merge. I'm going to put some extra data from another table, from the roots table, into the result as well. So if you want to merge two tables together, like a database operation, you can do that with Pandas too. And then I'm going to sort by number of trips. So that little chain of events yields a new table of roots by their number of trips. And then I've sorted by the number of trips. So here you can see this CCL route, which is the cable car, has the most number of trips. It's pretty, yeah. Now, don't be deceived. That doesn't mean trips in a day. What do you mean trips? Trips in what period? That means all the trips listed in the feed. That doesn't mean on a particular day. So you got to dig a little deeper if you want to know on a particular day. Because trips can only be active for one part of a feed and inactive like during another part of the feed where school holidays or something like that. Or maybe there's only some trips that operate on Christmas, et cetera. OK. So that was a little bit of Pandas play. And here's some more GTFSTK specific things to answer our questions here. One of our questions was about distance. distance traveled. And in stoptimes.txt, there's this optional field that tells you the distance in kilometers, or meters, whatever, that the trip traverses at each stop. In the beginning, it's gone 0 meters. After the first stop, maybe it's gone maybe 800 meters, and then the next one, 1,600 meters. That's optional information. It's often missing. It's going to be essential for us if we want to calculate distances traveled. There's a function called append dist to stop times in GTFSTK, which computes that from the shape of every trip. So a trip has a shape. The stops are geocoded as well. You can project the stops onto the lines of the trip and then calculate distances with Shapely to do that. So I'm basically doing the work that the transit agencies should have done when they were putting this feed together. But they're strapped for budget. They often don't have dedicated GIS teams to do this stuff. The GTFSTK can do it pretty well. So I added this field now, shape distance traveled, to our stop times. So now we can talk about distances, distance stats. Sorry. I computed something called trip stats to start with. And here's what that is. This GTFSTK will compute some basic stats for each trip, such as the start time of the trip, the end time, the ID of the start stop, the end stop. Is it a loop or not? Does it start and end at the same stop? The duration in hours, the distance in kilometers, the speed. Those are some trip stats. Yeah. You're seeing why this would be. I hope you're getting an idea now. This is pretty handy now for analyzing, figuring out what the transit agencies are up to with their scheduling data here. You can also compute some route stats from GTFSTK. Now we're getting to answering our questions here. So it's just the method. All the hard work is embedded in the method, compute the route stats. Basically, we're summarizing the trip stats. We're aggregating the trip stats at a route level. So the number of trips, for instance, the number of trip starts, the number of trip ends. Oh, that's weird. There's fewer trip ends than trip starts. That's because this trip, if you look down here, the start time is 5:40, and the end time is 24:45. It's the next day. So the route stats is computed for a particular day. So there's 4 trips that end the day after. This is useful. Max headway. So the headway is the time between trip starts, and the max headway is the maximum gap between trip starts. So that's the frequency of your route. You want routes as a user. You want routes as a user of public transport. You'd like routes that are frequent. So you don't have to look up schedules. You just turn up to the stop, and there's, a route will come soon. Trip distance, trip duration. Basically, these are all the stats that were in those questions in the beginning. So I'll just merge in some columns like the route short name to these stats, just using some pandas. And here we go, and some answers to our questions. The least frequent routes. It's that cable car again. So yeah, I sorted the values by max headway. So by frequent, I mean max. I want small max headway, small gaps. Cable car, operating a max headway 10 minutes. Wow, that's pretty reliable. I mean, as promised. Next is this one, Karori, Wellington, Hataitai, Seatown. The shortest, longest route. Okay, the cable car is the shortest. I guess probably would get to that. Anybody want to guess the longest route before I scroll over here? By longest, I mean the mean trip distance. So every trip has a distance. A route has several trips. I'll just take the mean of those distances. The Kapiti line. Let's see. It is the Wairarapa line, actually. Masterton, Wellington 1. So which was the field? It's this one, right? Mean trip distance. Oh, no, sorry. Mean trip distance is the third to last. 90 kilometers. It's a long one. Copy line 47. Slowest, fastest route, all right. Maybe take a guess at this. So by speed, I mean the service speed. Total duration divided by total distance. Sorry, total distance divided by total duration, AKA the service speed. Any guess on the fastest route? Wellingtonians out there? It's the cable car. Oh, no, sorry. That's the slowest route. Cable car is the slowest route. 7 kilometers service speed. Fastest route? Any guesses? The Kapiti line. 55 kilometers per hour. So the trains are pretty fast, as you'd expect. GTFSTK does a little bit of visualization. My employer was like, I wrote this, MR Cagney sponsored the development of this project, and they were cool with open source. They were like, but don't put in too much visualization stuff. That's our special in-house stuff. I'm like, all right. So there's a little bit of visualization. You can plot some routes. In-house, we have this cool web app that you can view feeds and stuff. This is GTFSTK. You can plot any routes you want. Here are the exceptional routes that came from the answers to our questions. And I'm using Folium here, which is a nice package for plotting maps. Highly recommend Folium. There's the Wairarapa line, for instance. And there's the cable car down there. There you go, with its stops. So, if you like what you saw here and you want to get into civic hacking yourself, actually, if you go to any hackathon, they're probably going to give you some public transport data. You're going to have to come and deal with this stuff. If you want to look more at what I did here, the Jupyter Notebook works. You can get it from GitHub. This will be posted in the follow-ons to the conference, I'm sure. But Python for Public Transport is the name of the talk. It's the MR Cagney repo. And it's got the Jupyter Notebook and the data, so you can run stuff, tweak stuff. Also, GTFSTK library is what I used here. There's a Transit Feeds API if you want to programmatically interface with Transit Feeds to get scheduling data. Also, if you want to put this stuff into a web app, there's this nice package called Django Multi-GTFS, which allows you to do that. So I've used that. Partridge, I haven't used. That was developed by Transit Mix, now called Remix. And that's for mostly reading GTFS data, not doing too much with it, but like reading it and subsetting it. And Pear Tree is for doing like network analyses on GTFS feeds. And if you just like transit in general, there's a cool GitHub repo called Awesome Transit, which has a lot of these libraries. So thanks, everybody, for your attention. I see I'm out of time, but if you have any questions, just feel free to catch me on a break. Unless you have one quick question now. Anybody have a quick question? Yes?
What are some of the common comparisons that you do between this sort of stuff versus the real time?
Real time. So, yeah, this is a good one. So we do this at work. It's like compare the performance promised versus the performance on the ground. So delays. The real-time feeds have delays encoded in them, so you can figure out like median distribution of delays for each route. And be like, for instance, if the route is highly irregular in its delay profile, it's like widely variable, that's probably a bad route. It's like, something's going wrong there. It's highly variable. Yeah, so that's one of the analyses you can do. You put all these three together, and you can answer a lot of interesting questions. So thanks again. Oh, yeah. OK.
Interesting things that you found about the Auckland
Oh, a lot of it is just performance stats that are not advertised. You know, you get the schedule, but it's interesting to see like route frequencies. It's like, oh, they advertise this route as frequent, but actually, it's operating at 11 minutes max headway, not 10 minutes or something like that. And a lot of times, transit agencies don't know exactly all the details, like they plan the routes. But